Alright, what's up? Got another video here for you. It's the general power formula. We're going to do some integrals. Alright, now you've done problems like this before in applied calculus. It's just that it was all polynomials. So just real quick, remember you might have had something like, let's do this, x squared plus 1 cubed dx. So you had something like this, something in parentheses raised to a power, and you would do what? Let u equal what's in the parentheses, and then du is 2x dx. So you'd have to multiply by 2, come out multiply by a half, and do all your substitutions and everything. So you've done that. Okay, so what's the difference in this video versus the other videos? Well, the difference is you see inside the parentheses here how you got a polynomial in parentheses raised to a power. Well, this time in this video, this is going to be, you can see here, you're going to have trig functions, logarithmic functions, okay, exponential functions in the parentheses raised to a power. That's the difference. But everything's worked just like what you've done in the past. Okay. All right. So and look, and here's your formula: u to the n. So you remember when you were doing U-substitution before, that's what you would do. You would let u equal what's inside the parentheses. You would make your substitutions, and you would end up with u raised to a power, and then you would just add 1 to the exponent, multiply by the reciprocal of the new exponent, and then of course plus c. And n is not -1. Okay, n can't be -1. What happens if n is -1? Well, that's in a later video coming up. Okay. All right, so let's go ahead and get started. All right, so look at this. Do I have something in parentheses raised to a power? Yes. This, you see this sine cubed here? And I'm just going to erase this real quick. That's the same thing as that. So I have sine x in parentheses raised to a power. Okay? That's what that means. I'm going to go ahead and put the exponent back here. But just remember, picture this as sine x in parentheses raised to a power. And so what are we going to do? We're going to, let me change colors. We're going to let u equal sine x. So du is cosine x dx. And so what do we get? We get the integral. Now in the place of sine x, we're going to put u. So that's u to the third. See that? And then look at this, cosine x dx, cosine x dx. I'm going to replace that with du. And there you have it. You see that? It's in this form now. We can use the power rule. So I'm going to get what? U to the fourth, multiply by the reciprocal of the new exponent, and don't forget to put your plus c. And so this is going to be 1/4. Kind of looked like a 9, didn't it? 1/4 sine to the fourth x plus c. We gotta put sine x back in for u. And there it is. That's your that's how you work it. Okay. All right. Let's look at this one. Now, do I have something in parentheses raised to a power? Yes. You see the square root? Remember how we look at square roots? That's in parentheses raised to the 1/2 power, right? And look at this. What's the derivative of 1 plus tangent? Secant squared. Do I need that 2? No, I don't need the 2. So I'm going to go ahead and rewrite this. I'm going to bring the 2 out. And I'm going to write this 1 plus tangent theta, parentheses to the 1/2, and then I've got secant squared theta d theta. Okay. Now, hopefully you remember in previous videos, okay, I explained why I pulled the number out. Okay. I pulled the number out because the derivative of 1 plus tangent doesn't have a 2 in it. You see that? The derivative of 1 plus tangent is just secant squared. I don't need the 2, so I'm going to pull the 2 out. That's why I'm doing that. Okay? And so this is going to be 2 times the integral. Well, I'm sorry. Getting ahead of myself. All right. So now let's do our U-substitution. So I'm going to let U equal 1 plus tangent theta. And so du is secant squared theta d theta. Derivative of 1 is 0. Derivative of tangent is secant squared. And so look at this. I'm going to replace this with u. And then look at this. Secant squared theta d theta. You see that? I'm going to replace that with du. And so this is 2 times u to the 1/2 du. Now I've got my power rule I can use. u to the 1/2. And so this is going to give me 2. That's going to be u. Add 1. So that's going to be u to the 3/2. Multiply by the reciprocal of the new exponent, which is 2/3, plus c. And so now I substitute back in. So that's going to be 4/3. And then in the place of u, I'm going to put 1 plus tangent theta to the 3/2 plus c. And there's my answer. All right, so I hope you see how easy this is. Okay, it's not bad at all. Don't make it difficult. Okay, don't make this difficult. All right, so let's look at this one. Integral natural log x over x dx. Well, do I have anything in parentheses raised to a power? Well, it doesn't look like it, does it? So this one may be a little more difficult to see, but let's take a look at it. Let's look at this natural log x here. What's the derivative of natural log x? What's the derivative of natural log x? It's 1 over x, right? Do you see a 1 over x here? Couldn't I write this as natural log x times 1 over x dx? You see that? Because, I mean, look at this. If you take natural log x times 1 over x, isn't that natural log over 1? And if I multiply that, I end up with natural log x over x. You see there? I just rewrote it like this so you could see it. So you can see the derivative of natural log x is 1 over x. It's out there. Isn't that what we're doing with U-substitution? We're letting u equal something, and then we do du, and we want it to be out here. That's all that is. And like I said, it may be, it was, I guess, a little more difficult to see it here. Okay? That's why I split it up. You don't have to do this step of splitting it up, but you can do it if it helps you, do it. And so I'm going to let u equal natural log x, and so du is equal to 1 over x dx. And so this is going to be the integral. Now look at this. You see the natural log of x, I'm going to replace that with u. And then you see the 1 over x dx, I'm going to replace that with du. And so that's going to be u du. All right. See, look, all of this is being replaced with du, and this is being replaced with u. And so this is going to be 1/2 u squared plus c. And so this is going to be 1/2. Now in the place of u, I've got to plug in natural log x. So that's natural log x plus c. Now let me show you this. We can do this, natural log x squared. Do you remember the other way to write that? We can put the exponent right there. So just remember, natural log squared x is the same thing as natural log x squared. Okay, those mean the same thing. All right. All right, moving right along to the next one. I think we only have like 2 more problems to work, so just hang in there. We're almost done. All right, find the value of this. All right, so let's just write the problem down. 0 to 0.5, and this is inverse sine over the square root of 1 minus x squared dx. All right, so this problem looks a little more difficult, but let's rewrite the problem. So I could rewrite this as 0 to 0.5 of inverse sine x times 1 over square root of 1 minus x squared dx. Okay, so why in the world did I do that? Well, look, the derivative of inverse sine of u dx is equal to 1 over the square root of 1 minus u squared times du dx. That's the derivative of inverse sine. Do you see it right here? See, in this case, u is x. All right. So let's let u equal inverse sine x. So du is 1 over the square root of 1 minus x squared times the derivative of what you're taking the inverse sine of. So the derivative of x is 1, and then dx. And so you can see I have that right here. So inverse sine is going to be replaced with u. And then look at this. I see all of that. That's right here. That's going to be replaced with du. All right. So this is going to be the integral. That's going to be u du. Oh, that simplified it up a bunch, didn't it? That made it real easy. All right. So let's see how we're going to work this out. All right. So we've got u is equal to inverse sine of 0. Remember, you gotta change your limits, right? So I've got to plug 0 in for x. And what's the inverse sine of 0? That's 0. So this is going to stay 0. And then u equals inverse sine of 0.5. Well, what's the inverse sine of 1/2? That's 30 degrees, or what? Pi over 6. Your limits have to be in radians. You can't put degrees. You got to put it in radians. And so we've changed our limits. And so this is going to be 1/2 u squared from 0 to pi over 6. And so that's going to be 1/2 times pi over 6 squared minus 0 squared, which that's going to be 1/2 times pi over 36, which is going to be, not pi over 36, pi squared over 36 when we square that. And so that's going to be pi squared over 72. And there's your answer. All right. So that wasn't, the problem wasn't really hard. It's just that you probably would have had trouble, or may have been kind of confused on what do you let u equal. Now this one might have been tricky for you, because the first thing that might have popped into your mind is, oh, I'm going to let u equal 1 minus x squared because it's under the square root, right? Parentheses raised to a power. But that's kind of what I've been talking about when I say you look inside the parentheses and you take the derivative and see if it's outside the parentheses. Okay? But on this one, when you look at it, you look at this inverse sine and you say, okay, well, what's the derivative of inverse sine? Well, it's this. So that's what you're going to let u equal, because you let u equal whatever, and then when you take the derivative, that derivative has to be out here. Okay, so that's kind of how you need to go about looking at it. And yes, I know pretty much all the problems we've worked so far, we've let u equal what's inside the parentheses or what's under the radical. Okay, but you know, there's exceptions to that. All right, so this is the last problem. This is our last one. So let's just go ahead and let me rewrite the problem down here. E to the 2x over the square root of e to the 2x plus 1 dx. All right, and I tell you what I'm going to do. Let's go ahead and erase that. E to the 2x plus 1 to the 1/2. Okay? Because when I look at this, what's the derivative of e to the 2x plus 1? Well, the derivative of 1 is 0. The derivative of e to the 2x is e to the 2x times 2, right? It's just e to the 2x times derivative of the exponent. And I've got this e to the 2x. See, I've got that there. I'm just missing the 2. But we know how to deal with that. You just multiply by 2, go outside the integral symbol and multiply by 1/2. Okay. Now, look, the U-substitution that we're doing right now, this is something that you should already know how to do, the U-substitution. We've been doing that in plenty of videos, plenty of sections up until now. It's just we've had polynomials inside the parentheses. But this time we got trig functions, log functions, exponential functions inside the parentheses. But it's still the same thing. You're still working it the same. All right, so I'm going to let u equal e to the 2x plus 1. And so du is equal to, that's e to the 2x times the derivative of what's inside the exponent, or I'm sorry, times the derivative of the exponent plus, not plus, times dx. And so you can see here, I've got the e to the x dx. See, I've got that. I'm just missing that 2 there. So remember, we can multiply by 2 and then come out here and multiply by 1/2. And so this is going to be 1/2 times the integral. And that is going to be, let's see, 1 over u to the 1/2 du when I make my substitution. And so this is going to, I'm sorry. U is equal to e to the 2 times 0 plus 1, which this right here, e to the 0 is 1, 1 plus 1 is 2, and I've got u equals e to the 1.5 plus 1, e to the 2 times 1.5, 2 times 1.5, that is e cubed plus 1. All right, so there's my, that's my new limits. So this is going to be 2e cubed plus 1. All right. And so this is going to be 1/2 And this is going to be what? 2e cubed plus 1. And that's going to be u to the negative 1/2 du. All right, so we're going to take the u to the 1/2 and move it up into the numerator. And so this is going to give us 1/2 u to the 1/2, right? Add 1 to the exponent and then multiply by the reciprocal of the new exponent. And that's from 2 to e cubed plus 1. And so let's just write this as square root of u. Let's change that to square root. This goes out to 1. And that's going to be 2e cubed plus 1. And so this is going to be the square root of e cubed plus 1 minus the square root of 2. And when you punch all that into your calculator, you end up with 3.178. And that's your answer right there. All right. And that's the end of the video. All right. So, in this video here, you're not really doing anything different than what you did earlier. Okay? Just remember earlier inside the parentheses, you had polynomials. And so you would let u equal that polynomial, and then you would have to take the derivative of it to get du. Well, earlier, we didn't know how to find the derivative of trig functions, log functions, and exponential functions. We didn't know how to find those derivatives. But now that we know how to do those derivatives, now inside the parentheses, you're going to have trig functions, log functions, exponential functions. Okay? That's the only thing that's changing, is instead of polynomials inside the parentheses, it's these other functions. But other than that, it's all worked exactly the same. Okay? Just like up here. Let's just look at this real quick. You see how I have this inside parentheses? Well, you knew from earlier, I'm going to let u equal 1 plus tangent theta. I'm going to let it equal what's inside the parentheses. But if you were to come across this problem back at the beginning of the course, du is, well, we wouldn't know that because we don't know how to find the derivative of tangent. We didn't know that back then, but now we do. And that's what I'm trying to get across. And I know I've said it 10,000 times, and you're probably wanting me to shut up about it. And I know you can just end the video now, but just listen to this. It's the same thing as the beginning of the course when you first learned how to integrate with U-substitution. It's the same thing. It's just that it's not polynomials inside the parentheses, but the procedure's the same. All right? And I'll shut up now and end the video. But I appreciate you watching. Check out my other videos. Give me a like, share, and subscribe. And I'll see y'all in the next one. Later.